Hello friends, welcome to my channel. This is the Boss Repairs, and today I'm going to show you how I fix this LG 32-inch TV. So this TV comes from a customer and it's not switching on. So I'm going to go through the steps that I used to diagnose this TV, and hopefully if you're faced with this problem, with the same problem at home, you can fix it all by yourself. So friends, this TV is not switching on, and together we're going to diagnose it. I will start by plugging it in to the current so we can check together. So you can see that it's on, but when you look at the TV you don't get any indication it's on. So what I did is I already took out the back side. I will just turn so you can see. I already took out the back side. This is how the board looks like. And with the help of my multimeter, my Fluke 107, I will put my voltage to DC voltage, the one with the straight line and the dotted line under. That's the DC voltage. This is the AC voltage, but I'm going to use the DC voltage to check the main capacitor, and I'm also going to use the AC voltage to check the input circuit, because when you don't get any power light on the TV, it's most definitely a power problem, or there's a problem with the second, either the primary section of the board has a problem or the secondary section of the board has a problem, which is short circuiting the primary section. So we're gonna check together and we'll see. And the first place to check will be this main capacitor here, to see if it's receiving charge or not. Because if this is not receiving charge, then nothing in this board will function. Because this, when it receives the charge, it takes in AC volts, sorry, it takes in DC volts, which it gets from the bridge rectifier, which has broke these 4 diodes here. These 4 diodes which break the AC to DC, and then this one stores the DC voltage which goes around the board and is used to regulate the DC voltages necessary for the TV to turn on. So without taking so much time, I'm gonna put my multimeter on. You can see it's on, and then it's on DC voltage. I will just quickly check the capacitor. This side with the stripe is for the negative probe, and the positive probe is for the other side with no stripe. So I'm just gonna go on it and I'll check. You can check on the multimeter. On the multimeter you're getting 90 volts, which is going down to 89 volts. So I immediately know that this is not correct, because I need to get at least 320 volts here, or something in the 300 range. Because if I'm getting 220 in, then I should get 300 and something volts, which has been boosted, because 220 is the AC voltage, and then it should be 320 volts here, or 300 plus volts on this capacitor. And I'm just gonna check it again so you see. So you can see it's 88 point, which keeps fluctuating. So definitely what is showing me here is the AC voltage that comes into this power, the voltage that comes into this board is not enough to power on this board, or to let this board function properly, because this main capacitor is not getting the voltage that it needs for it to function. So with that being said and done, I can tell you for sure with my diagnostics that the problem comes from this power section of the board. So what I'm going to do is I'm going to plug it out, and then I'm going to test how many voltage come in through the AC line, which must give me 220 on the multimeter. Then from there I'm going to continue to check. So without taking so much time, we're gonna go. I will disconnect it from power just so it's safe. Okay, it's disconnected. And just one note, you must be careful here, because even if you plug it out of power, this capacitor still keeps charge, and you can see it still has 86 voltage, and it can be shocked. It can shock you, and it can cause you to be electrocuted. So you must be careful and always try to discharge this capacitor. You can use a resistor, or you can use a screwdriver to short the 2 points, but I'm not gonna be dealing with that part for now. But it's just a caution, something that you can take caution with. So what I will do is I will plug out the AC wire. I will plug out the AC wire. and then what I want to do is I want to test the input to see how much input is coming out from the power. So I will plug it in. Be careful, this can cause shock, and to test that wire you will need to put your multimeter to AC voltage. And with AC voltage, it doesn't matter which is negative or which is positive, so long as the test probes are there. So you can see, I don't know if you can see, but it's giving me 100 and something voltage, which won't work in this situation because we are in the African zone. We use 220 voltage. This American uses the 120. So I will just show you quickly. You can see that is 120 voltage coming out from the power supply. So this will work for American power supplies, but it won't work for African. So what the problem that you're gonna have here, what we have to do here is either you can modify this system to boost it up to 320 from the system, or you will need a power cord that supports the 220 voltage, that gets 220 from the power supply. So sometimes it could be the fuse in here, that is because this power supply has a fuse. Sometimes it could be this fuse that is gone, but in this case this is not, because this power cable is American power cable. So this fuse is fine. I will just check it to show you. You just put your multimeter to continuity mode. So continuity mode, when you touch the two probes, it makes that beep sound. So I will put the one probe this side on the one end, and then I put the other probe on this other end. That shows the fuse is working 100%. So the problem here is this cable, and because this cable is not a 220 volts cable, it's a 120 volt cable, so the board is not getting enough voltage to power on. So this can be a easy fix, as it can also be a complicated fix. What I'm going to do is, I got this 220 cable, which I'm going to check before I plug it in, just to make sure that it's getting the voltage that I need for the board to power on. So I will plug it on. And you must be careful because this thing is having high voltage on it, since it can shock you. So you must be careful in how you handle it. Oh, sorry, I just have to put it back on AC voltage, and then I go there. You can see there, that's 205 volts. That is what we need. That is the voltage we need for this board to work. So I am rest assured that this board is gonna power on and everything is gonna work. And I'm also gonna show you how much this capacitor is gonna get charged, and you will see for yourself that that was the problem actually. So I'll plug it in. So I plug it in, then I plug in, and right away I can show you. Oh, sorry. So just take a look at the multimeter. I will check the, you can see that's 277 volts. Yeah, it's, if you sum it up, it's gonna reach 300 volts, and that is good for this TV to function. And that is where you check and you start. Every technician knows you have to check the main capacitor if it's getting voltages before you move on to your diagnose. So that is what I wanted to show you, and hopefully it helps someone at home which is struggling with the TV that suddenly just went off and doesn't switch on anymore. So if you found this video interesting, you can always leave a like and subscribe to our channel, for there's more video coming on the way. Please, this goes a long way to help the channel. Do subscribe to the channel. I'll switch it on. Do subscribe to the channel so that we can in return make more videos that will go a long way to help our viewers. So you can see the TV is on, the TV is working. The problem was just the 120 cable, which we fixed it easily. So do leave a thumbs up, subscribe to our channel, and if you like this video, do more to subscribe. We have a lot of new visitors, new viewers, but less subscribers, so please do subscribe to our channel for more videos are on the way. Thank you so much for watching, and see you in the next video. Bye bye.